What are energy levels? Energy levels roughly correspond to the old electron shells of the Bohr model. However, there are slight differences in the energy levels. I'm going to demonstrate them as best I can here. This picture below of the periodic table demonstrates the different energy levels. It starts off with energy level 1 and in theory goes to infinity, but the periodic table only shows 7 energy levels. What energy levels allow us to do is to separate some orbital types from other orbital types. So the 1 in the 1s here means that this first set of s orbitals is closer to the nucleus than the second set. So the 1s is closer to the nucleus than the 2s. Otherwise, if they were all labeled s orbitals, then we couldn't distinguish between which one is closest to the nucleus. That's the first thing that energy levels allow you to do. The second thing is that energy levels allow you to predict what orbital types will come in the future. That's demonstrated with this extra drawing over here. So this drawing looks like a little step stair, like you're going downstairs. And it's another depiction of what's on this periodic table right here. Each energy level has a different number of orbital types. As we go down or increase the energy level, we get more possible orbital types. At the start, we have the first energy level only has the s orbitals. The second energy level has the s and the p orbitals. The third energy level has the s, the p, the d, and so on and so forth. So as we add a new energy level, we also add a new orbital type. Once you get down to the fifth energy level, you start getting into theoretical orbitals. The first theoretical orbital is going to be G. None of those actually appear on the periodic table. They're just theorized as having happened or have the ability to have electrons in them. I don't know if anyone's ever actually seen electrons in them. But the electron energy levels and orbitals together allow you to predict future ones that may not have been seen. So if we were to relate this periodic table with this energy level diagram up here, then as we pass through the 1s orbital, we also pass through the 1s orbital up here. In this diagram, you go from the top right to the bottom left. As we pass through the 2s orbital, we also go through the 2s orbital here. As we pass through the 2p orbital, you also pass through the 2p orbitals here. As we pass through the 3s orbitals, you also pass through the 3s orbitals here. As we pass through the 3p orbitals, you also pass through the 3p orbitals here. As we pass through the 4s orbitals, you also pass through the 4s orbitals here. Next are the 3D orbitals, 3D orbitals, 4p orbitals, 4p orbitals, 5s orbitals, 5s orbitals. Next are the 4d orbitals, 4d orbitals, 5p orbitals, 5p orbitals. And down here will be, we can continue this, I just didn't have room. Down here will be the 6s orbitals. So this will be 6s at the bottom because we pass through here 6s. Then we go through what? So as we end at the 6s down here, we come back up to the 4f. Where are the 4f? The 4f are down here, down at the bottom. So this is where the f orbitals shoot in. Where the 6s ends, it actually goes back down to the 4f and through them, and then back up into the 5d and across the 5d. So that's here. We go through the 4f, through the 4f, through the 5d, through the 5d. And from there I can't continue just because of restrictions from space. But theoretically this can go on forever.